Welcome back. We're going to start 1.5 and it's all application problems. So we're just going to walk through some of the examples that we have, and different problems will require different techniques, but it's just going to take some time and exposure to get used to some of these methods that we have. So the first problem that I have for you today is a rectangular piece of metal is 10 inches longer than it is wide. So let me draw a rectangle. Once again, I apologize for my drawings, but it states, let's see, 10 inches longer than it is wide. So if we define this as width, then it's going to be 10 inches longer than it is wide. So this is what we're starting off with. And then the question states that squares with sides 2 inches long are cut from the 4 corners. So I'm going to cut out squares from each of the 4 corners, and the sides of the square is 2 inches long. So this is 2 inches here, 2 inches there, 2 there, 2 there, and so on. So this is the overall context of the problem. And if you want to see this example, it's taken from our textbook within that section. So go to 1.5 problems and you'll see it all written down, what I've just read to you. So the next part, it says, okay, so these squares are cut out and the flaps are folded upward. So we're going to have a fold here. We're going to have a fold across here. We're going to have a fold there, and then finally across here, to create an open box. And it states that the volume is 832 cubic inches. What is the dimension? So our goal is to find the dimension of the box once it's cut off and formed into an open box. So there's a lot of things for us to consider. So once the box is formed, and let me attempt to draw out this open box. So something like that. Okay, good enough, right? So we have this box. We want to know what this dimension is, what that dimension is, and also what this dimension is, right? Just keep in mind where it came from. So the bottom dimension came from here. So this dimension is going to be W plus 10. But remember, we cut out 2-inch squares from either side. So I have to subtract 2 and another 2 because it's taken off of each side. So the dimension of this part is going to be W plus 6 because it's 10 minus 2, which is 8, minus 2 again, so we have 6. So we found one side, and then the other side comes from here. Right, just this section. So if the entire thing is W and we cut off 2 2-inch sections, it's going to be W minus 2 minus 2, which is going to be W minus 4. So we have those 2 dimensions, and now we need the height. And the height is just going to be 2 inches because we folded along those cuts. So it's going to be 2 inches tall. Now putting that all together, volume is length times width times height. So plugging in values that we know, 832 is equal to W plus 6 times W minus 4 times 2. So to start off with, I could multiply these two binomials and then multiply that by 2, but since I have to solve for W anyways, I'm going to start off by dividing through by 2. So divide both sides. Once again, this is not the only way to do it. And if I divide it by 2, I get, let's see, 416. 416 is equal to W plus 6 times W minus 4. Now I can multiply, so you can use the box method, you can distribute, or use distributive property, you can do vertical multiplication to get this part down. And I have 416 equals W squared plus 6w minus 4w minus 24. And to solve for it, I want it to be equal to 0, right? So what I'm going to do is I'm going to subtract 416 to both sides. So I get w squared plus, and I can combine these like terms. So it's 6w minus 4w, so we get 2w. And if we do this addition, let's see, 0, 4, 4. So we get negative 440, and that equals 0, because we subtracted 416 from 416 from 416. Now we got to talk about factoring. So we're going to look at 440. We want to think about factors of 440. When you multiply, you want to get negative 440. But when you add them, you want to get positive 2. Right, so let's see, 440, and we want to get positive 2. So we can do 22 and negative 20. So if we multiply 22 times 20, we get 440, and their difference, or their sum, but one of them is negative, is going to be 2. So we can do w squared minus 20w plus 22w minus 440 equals 0. So keep in mind the order that you put this does not matter, so you could have put 22w minus 20w. And then factor by grouping. So, oops. Oh, I don't know why my... Okay, so from these two, I can factor out a w, so I'm left with w minus 20. And then from the last two, I can factor out a 22, right? So I'm going to factor out a 22, so I'm left with w minus 20 equals 0. And so they both have w minus 20 in common, so factor that out, I'm left with w plus 22 is equal to 0. So here is where we're going to use the zero factor property, as our textbook calls it, but it's more widely known as the zero product property, where if you have two things multiplied to 0, then either the first factor is equal to 0, or you can have the second factor equal to 0. And then we solve. So for this one, w is 20, and for this one, w is negative 22. So if we were just solving this algebraic equation, then we would have two solutions. However, we're putting it in terms of this context, right? So does it make sense to have a negative dimension? No. So our solution is 20, but the question asks for the dimensions, not what w, which is something that you've made, was. So if we're looking at dimensions, it's w plus 6, so it's 26, by w minus 4, so that's 16, by 2. So our dimension of our solid is 26 by 16 by 2, sorry. Okay, so it's our length times the width times the height. And to check that you've done this correctly, if you actually multiply it out, it should equal to our volume. And the unit is in inches, so it should be 26 inches, 16 inches, and 2 inches. So the dimension of the open box is 26 times 16 times 2, but I took a look at the problem and it actually asks the dimension of the rectangle that we started off with. So w was already the width that we started off with, so our width of the rectangle that we have is 20, and then the length is 10 inches longer than the width. So the dimension of the rectangle that we start off with is 20 inches by 30 inches. Okay, so once again, this dimension is for the box that was formed after you cut it out, and the actual solution for this problem, because it asks for the dimension of the rectangle that we started off with, is 20 inches by 30 inches.